Okay, hi grade eights. All right, so I think perhaps the easiest way to teach this unit, as brief as it will be, because again, we finished the last unit. Hopefully you did your make your own exam assessment for algebra, the chapter 10. So this is chapter 9, and again, we're barely going to visit this unit. We're just going to do some analysis. And so this is chapter 9 in your textbook, and this particular problem is from page 357. I just posted it right out of the textbook. All the grade 8s got these 4 problems modeled to them. So let's get into it. This is number 5 on page 357. And I'm just trying to show you this as an example of how all this stuff works, okay? If you remember from the last video, right? I was trying to show you, look how beautiful that is. I was trying to show you how the equation relates to the graph, relates to a table of values, and vice versa, and you can go any direction and yada, 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 okay? So let's read this thing out. A long distance telephone plan can be represented as C equals CT, okay? So without even reading further, it would appear that they have given us a formula, right? An equation, okay? Again, I'm using formula and the word equation like they're pretty much interchangeable. Can be represented by C is equal to 6t, where C is the cost in cents, okay? So they're defining the variables for us. And the t is time in minutes, okay? A, make a table of values, at least 4 whole numbers for values of t. Graph the ordered pairs. If part minutes are rounded up to the next whole minute, is it reasonable to have points between the ones on your graph? Explain. Okay, let's start with the beginning. So in our little, just to use our little representation here, okay, and I'm going to abbreviate it. So you have, we can get an equation, right? And then what did I say? A table of values, which I abbreviate as TOV, table of values, right? And then we're supposed to have a graph, right? And of course, these are supposed to be double arrows because you can start anywhere. But we've been given, right? If I just want to switch a color here, we've been given the equation. That's our starting point. And we need to do, look at A and look at B. So this is A and this is B, right? It says, give me a table of values, give me a graph. Okay, well, let's start with the table of values. Let's decide where we need to put all of our data and our letters, okay? So we've got an equation that says C is equal to 6t, okay? I'll just give you a basic hint here. If normally our table of values goes like this, where x is on the left and y is on the right, okay? So if you have a graph, right? Oh, Lordy. Let me pretend to use straight lines. There we go. Okay, so let's say you have a graph, all right? Close enough. Your x is down here, right? It's the horizontal, and the y is up here, okay? It's the vertical. And generally, your x's go on the left, and your y's go on the right. So you may be asking yourself, but Mr. Smith, I don't have an x and y. I have a c, I have a c, and I have a t, okay? I have a c, and I have a t, all right? I'm just going to... Now that I've quoted them, I will just make sure it's not so cluttered. So where do they go? Okay, where do they go? Well, if you were to write this, if you had to write this using the letters X and Y, do you think it would look more like this? Or do you think it would look more like this? And the answer is, it's this one, okay? I answered that very quickly because I don't expect you to know it. Usually when you have a letter equals, the single letter by itself is the Y position. Like if it was written like this, and this whole side here has a bunch of numbers, let's say it's minus, 3.9, whatever. The variable that has all the complicated stuff attached to it, whether it's a coefficient here and a constant there, that is going to be your X value. And this one's going to be your Y value. Okay, I'm not going to spend as much time in the future, diving into this part, but I think it's important for the first example. How do we decide where the letters go? Okay, so now I'm just going to undo all of this, okay, just give me a page. I'm just going to pause the video here. Okay, I'll be right back. Okay, I'm back. So I just wanted to make sure we had a fairly clutter-free space. So what I was trying to say to you is that this was going to take the Y position because it's the letter by itself. It's equaling to C. Okay. Last point I also want to make here. If this had been written 6t is equal to C, okay, pay attention here, this would still be the Y value, okay? Again, it's the lonesome little letter by itself. And the number that's, when we have a coefficient type, this is the X, all right? If you're ever confused, just ask me. But you also have to look at it from this point of view, okay? I'll say this a different way. Look at it from a point of view of dependency, okay? Dependency. The cost, how much you're spending is dependent on the amount of time you spend on your cell phone. The cost is dependent the amount of time on your cell phone, okay? Maybe that was a better way to explain it. So the cost will go here, right? The cost is dependent on the time that you spend, okay? The cost is dependent. This is the way it should always be set up. Whatever letter depends on the other letter, the other thing, that's the way you should set up, okay? In other words, I don't know if Ms. Heshe or Ms. Norris or Ms. Mitri have said this, but X is the independent variable, okay? X is the independent variable, and Y is the dependent. I really emphasize this, grade 8s, because your table of values are not always just going to be set up like X and Y, right? You could have a T and a C, right? You could have, there's lots of ways of doing this, right? You could say your growth, right, depends on the amount of sunlight, okay? There's lots of ways of doing this, okay? So I'm going to pause the video once more and clear my screen. Okay, so one last time. Our cost, the way this is written, our cost, just use an arrow here. Our cost depends on time. So time, therefore, is our X, and C is our value. All right, let's start plugging this in. The easiest thing to do is, where students kind of get a little messed up is they don't know what numbers to use. And I always tell them, start with simple numbers. What if you don't use the phone at all? In other words, you spend 0 time on the phone. Well, if you spend 0 time on the phone, it shouldn't cost you anything, right? If only cell phones work that way. If you spend 1 minute, right? It says time in minutes. If you spend 1 minute, then it's going to cost you, C is the time in cents. Wow, I wish cell phones really were this way. 6 cents. If you spend 2, right? If you spend 2, right? What's 2 times? So 0 times 6 is 0. 1 times 6 is 6. 2 times 6, so we're saying what happens when t is equal to 2, right? When t is equal to 2, if we spend 2 minutes, just to explain how this is working, we go 12. By now, I think you can see a pattern, right? By the time you spend 3 minutes, it's 18 cents. By the time you spend 4, okay, it's 24. Okay? So, I do want room. I've got a cut and paste snip of a graphing paper, so I'm just going to erase this portion here and make room for it. But basically, we've answered A, haven't we? Haven't we succeeded in answering A? Right? Can I give myself a little happy face here? Okay. So I did a table of values, so that's good. Done. Let's do the graph. Okay, I'll be right back. Okay, so we're back. Just going to move my face over here. So here's what I'm going to do. I've already got some graphing paper somewhere in this little, there we go. I don't think we're going to need okay, let's just try this one. All right, so I can move this around. I can make it bigger. Let's make it bigger. Okay, so yeah, you need some graphing paper here, all right, grade 8s. So we got to start labeling all of this stuff. So up here, let me use, let's go back to, let's do dark orange. Okay, so your graph needs a title. Whoops. Your graph needs a title, so let's go with cost of long distance plan. Okay, so long distance plan. I'm just going to abbreviate that because the focus is on the math. The cost of a long distance plan down here is time. Okay, so we're labeling. You may want to put the actual variable that you put. Oops. Let's just use a bracket. And you could even put the units, right, in minutes. Okay, now, so this is your so-called little x value. Your time is along here. Now, your cost. Okay, so that's along the y-axis up here. So your y-axis is your cost. Okay, so your cost. Your cost, C, okay, in, what are we doing? In cents. Boy, what a smoking good deal this is. So your cost C in cents. It's a little far away from this side here, but, bear with me. Okay, so you got 0. Now, how are you going to label the time? Well, the time seems to be going up by 1. I think it's fair to just say, look, why don't we just go up by 1? Could we have skipped the space? Yeah, maybe, but then we don't have a lot of room here, okay? So I'm just trying to keep it simple. Now, what about the cost? Well, could you go by 6? Yeah, you could. Sure, why not? So we're going to go by 6s. 6, 12, 18, 24. Yep. Felt I skipped something there. Okay. And then 30, and so on and so on. 36. Okay. So what are our ordered pairs? Well, our ordered pairs are just, they're bosom buddies. They're best friends. So 0, 0 is an ordered pair, right? 1, that's a 0. 1, 6, right? 2, 12, okay? And so on. 3, 18, and 4, 24, okay? Now, by the way, it says at least 4 numbers. I used 5, so no big whoop. Okay, so just going to pause here for a second. Okay, sorry, I had a little thing with my phone there. Where did we leave off here? So at 424, that's a really nice looking 2 there, Mr. Smith. And you can start plotting these, all right? So let's use these blue here. And let's go, well, you know what? I'm going to make this just a little bit bigger. Okay, so, well, here's 1 point, 0, 0. Here's another one, 1, 6. Here's another one, 2, 12. Here's another one, 3, 18. Here's another one, right? And so the nice thing about the graph is, could we keep going? Yeah, we ran out of data on our table of values, but could we have kept going on our table of values? Well, of course we could have. And we can extend, we can analyze this graph and we can make conclusions about it, right? It's pretty obvious. This is a very simple relationship between cost versus time, right? If the relationship is 6t, then you could just say, well, look, how much does this cost me after, let's say, when t is equal to 20 minutes? Well, at 20 minutes, you multiply by 6, right? Your cost would be 120 cents or $1.20, right? That's what the whole point is. All right, so did we get this done? Yeah, we graphed the ordered pairs, okay? All right, now let's go to the last part. I think I'll use hot pink here. Okay. Now, if part minutes, this is where some reading comprehension comes in, right? If part minutes are rounded up to the next whole minute, is it reasonable? Okay. If they are rounded up. So we're saying if you have a phone call that's 1 minute and 45 seconds, right? They're saying that's going to count as a 2-minute phone call. All right. Okay. 2-minute phone call. Sorry, that's going to drive me crazy. Let me rewrite that. And let's also just decrease this a little bit. Okay. 2-minute phone call. So 2 minutes. Now, what they're also saying, remember, the cell phone companies, a lot of businesses, they'll break the rounding rules. They don't care about the rounding rules. So let me just say this. A 1 minute, and so 1 minute, comma, 1 minute, comma. a 1 minute and, well, let's just say 8-second phone call. Now you would say, but isn't that close to 1 minute? No, 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 not for the purposes of business. They'll round that up too. Okay? They want to make money. So it says, if part minutes are rounded up to the next whole minute, is it reasonable to have points between the ones on the graph? And the answer is no, it's no point. We're not going to discuss the phone calls that take 1 minute and 30 seconds or 1 minute and 42 seconds. No, we're not going to do that. Okay? We're not going to talk about phone calls that last 30 seconds. We're not going to talk about phone calls that last 2 minutes and 17 seconds because they're going to get rounded up. So we don't want to join these points. We don't want to draw a line. It's not reasonable because it just told you the key sentence, the key part here was it just told you that if part minutes are rounded up to the nearest minute, well, then for the cell phones company point of view, there's no such thing as a 3 minute and 22 second phone call. That's a 4 minute phone call. And so you're going to get charged what? 24 cents. Okay? Lots of companies do this, by the way. They always, I won't say always, but they often round up in their favor. Okay. Hopefully that helped. I just wanted to show you an example. There's 3 more of how a graph, table of values, and equation, right? They all relate to each other, okay? I'm going to try and make the other example shorter. I felt this first one, I should really take my time, okay? All right, we'll see you later, okay? Cheers, grade 8s.